So Riemann changed the s, the exponent, the divisor exponent, in 1 divided by n exponent s infinite sum series by introducing this complex s, an s which is not equal to greater than 1 to whole numbers, but an s that is equal to sigma plus imaginary t interval. And so, Riemann said that it is in the sigma 0.5 in which all the non-trivial zeros exist. So it is only in this particular exact 0.5 in which both the cosine and the sine vanishes, or both are cancelled out, both are 0. And then, so while I'm making this second video, because I thought about it and I was like, the cosine, the x-axis, I didn't feel like I depicted it accurately, but actually, because I always made the highest number of zeros, the value with which is closer to 0, with the most number of zeros to be closer to the 0 line. Whether or not x-axis the sign is positive or negative, the graph actually still is the same, because I'm still, I'm still organizing it so that the x-axis will be on the left side. The values with the most digit will always be on the left side, and the higher values, whether positive or negative, the less zeros will always be on the right side. So it's going to be from the highest number of digits to the lowest. So that's always going to be the format, whether it's positive or negative. So the visualization was actually accurate. It's just that I need to also make it clear that the cosine, the x-real cosine, does change. It changes with whatever the sigma inputted. So if I enter 1.6, so from 0 to 1.5, it's going to be positive. If I enter 1.6, now the signs change to negative. And throughout the whole interval, the whole whatever interval, it's going to stay positive. So the sigma is the one controlling which quadrant x real is going to be. It is not the interval itself. So the interval for sine, it does change the signs. So the sigma does not affect the sine. The y imaginary sign changes as t increases, but the cosine itself is changed by the chosen sigma. So, and then throughout the t intervals, it's going to stay the same. And so if I change it back to, if I enter 4.8, then it's all going to be positive. So it's by certain x times pi divided by 2 that it's going to change. So that's how the x real cosine is going to change that way. So it's because that's the real part. The sigma part is the real part, and so the sigma controls the leading non-zero digits, and then but the interval does affect cosine in terms of how many zeros it will, like how the magnitude, like how that it's going to change the magnitude of the values as t increases. And that's the same for the sine. It's going to keep it more and more zeros are produced, but the sine, the y imaginary, is actually its leading numbers. Non-zero digit numbers also changes. It's different each time for each t interval. But for cosine, it's the same. So it's same signs, same leading non-zero digits for the x real cosine.